Consider two balls, one with a mass of 1 kilogram and the other with a mass of 10 kilograms. Which ball would experience a greater change in motion if kicked with the same force? Clearly, the smaller ball would experience a greater change in motion. An object's state of motion can be described as its velocity, where velocity is the speed of an object with respect to its direction. Objects at rest, for example the balls you see on the screen, have zero velocity. Once kicked, the ball's state of motion changes. In other words, its velocity changes. When an object changes its velocity, it has what we call acceleration. Newton's second law of motion provides the explanation for the behavior of objects when forces are applied to the objects. The law states that external forces cause objects to accelerate, and the amount of acceleration is directly proportional to the net force acting on the objects and inversely proportional to the mass of the objects. Notice that Newton's second law states that the amount of acceleration is directly proportional to the net force acting on the object. Well, what is net force and how do we calculate it? Net force is the sum of all the forces acting on an object in a particular direction. Since forces have direction, they are vector quantities. Vector quantities are fully described with both magnitude and direction, and they're represented with arrows. Consider an object being pushed to the left with 10 newtons of force and being pushed to the right with 5 newtons of force. The net force acting on this object is 5 newtons to the left, as 10 newtons minus 5 newtons equals 5 newtons. The forces are subtracted from each other since they are pointing in opposite directions. Now, the forces would be added to each other if they were pointing in the same direction. Once the net force is determined, the acceleration of the object can be determined. Acceleration is a change in velocity. As long as we know the mass of the object and the net force acting on the object, we can determine acceleration. Let's look at the formula. Acceleration equals the net force divided by the mass, where in the formula A equals acceleration, F parentheses net is the net force acting on the object, and M is the mass of the object. Let's look at an example. Consider a 10 kilogram object, forced to the left with 10 newtons and forced to the right with 20 newtons. What is the acceleration of this object? Let's recall the formula for acceleration. Acceleration equals the net force acting on the object divided by the mass of the object. So we have to first calculate the net force. As the forces are acting in opposite directions, we subtract them. So the net force is 20 newtons to the right minus the 10 newtons to the left. And we get a net force of 10 newtons to the right. Now, plug that net force value into our equation with mass to calculate for acceleration. Acceleration equals 10 newtons divided by 10 kilograms, or 1 newton per kilogram. A newton of force is equal to 1 kilogram times meter per second squared. If we substitute this value for a newton into the equation, mass is canceled out, and that leaves us with the units meters per second squared. Those are the units for acceleration. Therefore, the acceleration of our object is 1 meter per second squared. If we know the mass and acceleration of an object, we can calculate for force. We'll simply rearrange the equation to solve for force. So, as you see on the screen, the net force is equal to mass times acceleration. Let's look at an example. Consider again our 10 kilogram object, now moving to the west with an acceleration of 10 meters per second squared. What is the net force acting on this object? Recall the equation for force. Net force equals mass times acceleration. So we simply multiply 10 kilograms, the mass of our object, by 10 meters per second squared, the acceleration of our object. And that gives us a net force of 100 kilograms times meter per second squared. If we recall, those units, kilograms times meter per second squared, is equal to a newton. So the net force equals 100 newtons. Therefore, our object is being pushed to the west with a net force of 100 newtons. Newton's second law implies that acceleration occurs only in the presence of an unbalanced force. If the forces acting on an object are balanced, the object is in a constant state of motion. That is, it's not accelerating. Now, this is true for objects at rest as well as objects moving with a constant velocity. For example, a parked car has a net force of 0. The forces are balanced as the force of gravity pulling down is canceled out by the force of the ground pushing up on the parked car. Likewise, a car moving with a constant velocity, 65 miles per hour, is experiencing balanced forces as well. If an unbalanced force is applied, the car will accelerate.